Well, good morning, folks. Beautiful, sunny, late spring morning here in the harbor. Summer does look to be arriving, hopefully. Today I want to talk about a relatively mundane topic, but as usual from a slightly different perspective. And the topic for today is power inverters. Way back here in the corner, this black box next to the Cuisinart, I'll get to that in a moment, is a trip light 600 watt 12 volt DC to 120 volt AC inverter. And that is the largest inverter I keep on Cheris. That might seem like a strange thing in this day and age when everybody's running large lithium battery banks and electric heat, microwaves, electric cooktops, convection equipment. Anyway, I learned early on, I was helping a buddy do an installation on a boat. He was installing a large 2500 watt inverter on this, probably about a 35-foot sailboat, and I was helping him with the wiring, and we got it all wired up, and we got down to the battery bank, and I noticed that this large inverter was wired up to an 85 amp hour lead acid house battery. And I asked my buddy what this owner was thinking. Like, you wouldn't even be able to warm a cup of coffee in the microwave with the capacity of that battery, and he just kind of shrugged his shoulders and said that's what he wants. Now fast forward to 30 years later, and everybody's got these huge lithium battery banks that I fully realize for the same size and weight can actually power that microwave and probably cook a full Thanksgiving dinner. But if you watched my earlier video and discussion about my philosophy on batteries, battery banks in general, you'll know that I view lithium as a systemic conversion. They're not drop-in. And I'm not yet at the point of replacing my whole DC electrical system to the degree that I believe would take full advantage of a lithium conversion, among other concerns. Anyway, suffice to say that when I chose this size inverter, it was because I knew that there's no point to having an inverter your batteries can't feed. So what's the whole purpose of an inverter in the first place? Well, I guess what I would say is that you want to be able to run household appliances, normal household appliances. In this case, as you see, the Cuisinart. Got my coffee grinder back here, my stick blender that makes my morning smoothie. Note that none of these are high power consumption devices. And here's the key to knowing what size inverter you need. Each of these devices, somewhere, in this case right here on the handle, will have a stated wattage. And your inverter needs to be able to handle that wattage. If that device uses an AC electric motor, as do these, all of these, then you have to factor in the starting inrush current, which can be up to 4 times the running current. So your inverter, a 600 watt inverter, you might think can run a 600 watt appliance, and in some cases yes, but if it's an AC motor, no. You will often see both a surge and a running wattage on inverters because they can handle a very short spike of inrush current. In this case, this trip light inverter is sort of an industrial model, and it's pretty much just 600 watts. So what that means is that I'm looking, when I'm shopping for appliances, that want about 150 watts or less. And again, it's a systems approach. You don't just go down to the local department store and buy an appliance and bring it home. Well, you can, but it may or may not run off your inverter. And if you thought about it as a system, what you've got to do is sort of match the components within that system so they all play nice together. So as I say, my main inverter here is 600 watts. That inverter is actually wired into my main AC panel and a selector panel that allows me to choose only one AC source, whether it's the inverter, the generator, or shore power connection. And I do have to be selective. If I were to throw the inverter on with the water heater switch on, it would overload and trip the breaker. That breaker is actually here on the main panel. And one thing I would note about the inverter breaker is that it has, I don't know if you can see it in video, but it has an indicator light, and it's now feeding the main panel, so I'm seeing the voltage and amperage on my monitoring meters. So I want an indicator light because I don't want to leave that inverter on. Why don't I want to leave the inverter on? And why wouldn't I just put an oversized inverter in? Well, those are fair questions, and that's what I want to dive into now, because my whole philosophy about many things, not just inverters, is a philosophy of not what can I have, what can I get, what can I expand to, but it's a philosophy of what do I need? What is it that is required to accomplish what I'm trying to do? And that doesn't lend itself to just throwing in the biggest and largest that the dollar signs indicate. It lends itself to understanding the overall system. So that's what I want to talk about today. So thanks to the miracle of the internet and a little help from my friend Google here, the thing I want to discuss today is what your inverter is actually accomplishing. Of course, it's on the surface easy to understand that if you can turn your battery power into normal 120 volt AC current here in North America, then you can go and buy normal appliances that you would use in your home for things like your galley, and as you'll see in a moment, for your grooming, your toothbrush, grooming devices, shaver and toothbrush, that sort of thing. So the ability to have 120 volt power on hand will save you a tremendous amount of need for special appliances. However, if you think about what an inverter does and how it works, if that inverter is on, it's sitting there watching for you to demand power. So you turn your inverter on, assuming that that you don't leave it on all the time, which I know some folks do, and that's more to the point of this discussion. When you turn that inverter on, you're essentially going to charge up a whole bunch of capacitors in that inverter, and their job is to watch for you to turn on an AC appliance and have enough energy stored that there's no delay in the power to that appliance. It doesn't make you sit there and wait until it builds up enough current to run what you are trying to run. There's a cost associated with that, and again, thanks to the Google machine, a typical inverter uses between 5 and 50 watts of power when it's turned on with no load attached. This idle consumption powers internal cooling fans, control circuitry, and the transformer. I would say the capacitors, but anyway. So back to the point of why I'm using just big enough inverters on Charis, and I'll show you a couple more as we go through. A small inverter, 150 to 400 watts, usually draws less than 5 watts at idle. A medium inverter, 1,000 to 2,000 watts, is looking for 10 to 30 watts with no load. And a large inverter of 3,000 watts or better is going to use anywhere from 30 to 100 watts. That's right. I said 30 to 100 watts with no load on the inverter. So if your system is designed for that, if you've got a megawatt lithium battery system that doesn't care about a constant draw of 30 to 100 watts, then you can save yourself the sort of the aggravation of having to go and flip a switch, or you really can have your inverter just on all the time and not worry about it. And these are the sort of inverters that people are going to use if they're running a fully electric boat for cooking and all the other purposes. And that's the kind of parasitic draw that you can expect. On the other hand, if you've got a 400 amp hour lead acid battery system, you certainly are not going to be happy about a continuous 30 amp parasitic load. That's going to put a dent in your ability to replace that power, and it's going to reduce the usefulness of your overall power harvest for a day. So moral of the story is, the larger the inverter, the larger the idle no load parasitic draw of that inverter is. Now again, if you're switching the inverter on and off as needed, that's less of a concern. But if you're using the inverter, like a lot of us do, to recharge your electric toothbrush or your laptop or your whatever else, then what you have to bear in mind is that that parasitic draw doesn't care that you're only pulling 5 watts. If it's a 3,000 watt inverter, that 5 watts just became anywhere from 35 to 105 watts. So large inverter, large parasitic draw, extremely inefficient for long-term small power consumption loads. And that's the core of my choice to use multiple small inverters rather than one large one. Okay, so back where we started, here is what I'll call my main inverter, since it's tied into the main electrical bus and the main AC panel. Incidentally, this location on the galley counter might seem strange to some folks. And a little sidebar story on that. When I first installed one of these, it was actually out here in the starboard sail locker, and through a mistake of my own and a lack of a selector panel here, there was an incident that, well, let's just say there was a fire within that inverter. Thankfully, it was contained within the metal cage of the inverter, did not spread to the locker. But to this day, 35 years later, I can open my toolbox and smell the smoke from that fire. So when I replaced that inverter, not only did I prioritize the construction of a single source selector panel, and that is critical. Please do not tie in an inverter where it can in any way possible be paralleled with any other AC power source. You will cause a fire. Anyway, that inverter is on the counter. If there's a problem with that inverter, I literally, within reach, as soon as I see or smell smoke, can come up here and turn it off, depower the whole thing. I can also depower, disconnect it from the AC bus if I see that there's a voltage issue occurring. So that was a deliberate installation. I'd love to have that counter space for something else, but the reality is I consider it worth keeping an eye on that little bugger. So, as I said, main inverter, 600 watts, adequate for my kitchen appliances. There's a couple others that are stashed away, a hand mixer, I don't know, anything you might find in your household kitchen. But 600 watts is proven adequate for that, and the parasitic current draw of that is fairly low. But it's also, if you notice, all located in an area where there's no need for me to leave it on, because it's very easy for me to just throw this breaker and power up that AC bus only when I need it. So that one, the only time that's used for charging is if I've got to do say a drill battery or something that charger is a little more power hungry, so I'll tend to use that inverter for it. But again, it's right there on the counter, it's all visible, it's all in front of me, so as soon as the battery reaches charge, I can switch everything off and avoid the parasitic load. Now, coming up to the midship area here, this is my chart table, and in there, hard to see, but inside that you can see my laptop. So the laptop, of course these days laptops are powered mostly by USB-C connections. That's how my newest one works, but When the laptop wanted an AC power connection, older generations of them, the sensible and easy thing to do was for me to, in this locker, wire up another small inverter. I think in this case, this one's probably about 300 or maybe 200 watts. It's a smaller size one. That inverter is wired into the main AC bus. Sorry about the bad light in here. And over here, again, on the main panel, I have a computer breaker. And on the outside of the locker, I have a blue LED that tells me that that inverter is powered up. And so that inverter its function is to run, as I say, any charging devices where I may not be in attendance when they reach full charge, and I don't want the parasitic draw associated with a 600 watt inverter. So here you've got one about half the current, approximately half the parasitic draw. And finally, coming into the land of TMI, sorry folks, this is the head, and I don't think there's anything weird about wanting to have an electric toothbrush and keep it charged, or electric razor. But those items are extremely low current draw. So in here in the head, what you've got is a 60 watt inverter. This inverter is run from a lighter plug, which plugs into this lighter outlet. And as you see, powers up my small grooming appliance charging inverter. Again, 60 watts, 1/5 the computer charging inverter, and correspondingly significantly less parasitic draw. So this is the one that most commonly is going to be turned on and left on when I leave the boat, so that these items are charged up, particularly on a nice sunny or windy day when I'm making excess power. But at the same time, there is the very minimum of parasitic draw when these devices, my toothbrush, my shaver, whatever else is plugged in there, there is the very least parasitic draw when they have reached full charge and turned themselves off. So what you see there, basically 3 different inverters, 3 different purposes, and 3 different parasitic power draw requirements. The largest one being the most used with the kitchen appliances every day, but also being the most simply activated and deactivated. The middle one in the locker above the chart table, half, again, the size of the galley inverter, and then the forward one in the head, which is 1/5 of the size of that. So it's a different approach, and it's an approach that goes back to again the origin or the idea that the right way to accomplish something is with just the right tool. Don't use a sledgehammer to drive a finish nail. I think that's how I'd sum up my philosophy about inverters. And I realize that this might have limited interest, because the thing these days is to just go with your lithium battery bank size as big as you can possibly stuff into the boat, and not worry about these things. And more power to you if you're able to do that, if that matches your goals and your philosophies. I don't disparage that. It's just not my philosophy. It's not the way I've decided to go, and this is just an explanation of why you don't want to sort of mix your approaches. It would be absolutely pointless with 400 amp hours of lead acid battery for me to install a 3,000 watt inverter, because the current draw would be so high that the useful operating time of that maximum output would be negligible. But the parasitic draw, when that inverter was on, would be considerable. So here's a really simple way to keep your life simple. I guess the final thing I would say about this approach is that you could buy probably 3 of each of these inverters, and the total price wouldn't add up to the cost of a single 3,000 watt inverter. So this is also an inexpensive approach to getting the job done, and failure of one of these inverters will not necessarily leave you without any AC power at all. Anyway, that's the discussion for this week. Hope you enjoyed it, and if you got something out of it, please give the video a like and a share. Try and spread the word and grow the channel, maybe. Enjoyed having you aboard with me this morning, and I look forward to talking to you next week.